So in this question here, we want to calculate the curvature of this curve at x equals 1. Now the curve is the graph of y equals 1 over x squared, which we've got here on this diagram. Now the curvature, what that represents is, we want to get the point on the graph where x equals 1. So let's put that there. That's x equals 1. So let's just write that on. And then what we're interested in is the radius of a circle that will fit in to this bit here snugly on this part of the curve. So what we're looking for is to try and find a circle that will fit there nice and tight to the white line. Now the curvature, what that represents is the tightness of this curve. So obviously it's related to the radius of the circle. So for example, if I've got a circle, one here with radius 1 and one here with radius 3. Now the radius of curvature, so if I put that here as ROC, radius of curvature, that's calculated by the Greek letter rho. So this one will be represented by rho 1 and this one will be rho subscript 2. Now the radius of curvature of this one is going to be 3, this one is going to be 1. So this one is going to be larger. Now curvature is slightly different. So if I write curvature, that's going to be represented by the Greek letter kappa. So kappa 1 and kappa 2. What curvature represents is the tightness of the curve to go round there. So for example, if you're driving in a car around this one, you'd have to turn the steering wheel a lot sharper than you would on this one here. So in this case, the kappa 1, the curvature of this one is a lot sharper, so it's a higher value. So kappa 1 is going to be larger than what it is on kappa 2. Now, the radius of curvature, we know that's represented. So if I put the Greek letter rho, that's represented by a ratio between the first derivative and the second derivative. And we write that as 1 plus the first derivative squared. And then we raise that to the power of 3 over 2. And then we divide it by the second derivative. So that's how we find rho. Now the relationship between rho and kappa is pretty straightforward one. One is the reciprocal of the other. So basically rho equals 1 over kappa. So their kappa equals 1 over rho. So if we can find the radius of curvature, we can quite easily find the curvature. So at the point x equals 1, what we want to find is, first of all, let's find this radius. So that's what we're looking for. So let's plug that all into here, and we're interested at the point x equals 1, because if we tried it at a different point here, we could get a much different kind of circle in there, and same here and so on. So let's first of all, let's calculate what we've got. So y equals 1 over x squared. Now as I'm taking derivatives, I'm going to write this in slightly different notation. So I'm going to put x to the minus 2. Now we need y prime. So y prime, that's the first derivative. So minus 2x to the minus 3, which is minus 2 over x cubed. So that's the first derivative. And then the second derivative is just the derivative of this. So now minus 3 times minus 2 gives me 6. Drop the power by 1. So now I've got 6 over x to the 4. Now we're interested in the curve at x equals 1, so we need to evaluate these at x equals 1. So I want y prime at x equals 1. So I've got minus 2 over 1 cubed, which just equals minus 2. And then the second derivative, same similar situation, y double prime at x equals 1. That gives me 6 over 1 to the power of 4, which just equals 6. Okay, right, let's calculate first of all the radius of curvature. So let's just draw a line down here. So the radius of curvature, that's going to be 1 plus y double prime at x equals 1. So y prime at x equals 1 squared. So that's minus 2 squared and then we raise that to the 3 over 2, and then divide that by the second derivative at x equals 1, which is 6. Okay, so now we've got 1 plus minus 2 squared, which is 4, so that's going to give me 5. So I've got 5 cubed and then the square root of that divided by 6. So now I've got square root of 125 over 6, which is going to give me, inserts 5 root 5 over 6. So that's my radius of curvature. But what we want to find is the curvature. That's our goal. So the curvature is the reciprocal of this. So therefore we want kappa, which equals 1 over p. So that's 1 over 5 root 5 over 6, which is just the same as 6 over root 5. Okay, so plug that into a calculator, we'll get something that's approximately, so that's an approximate to 3 decimal places, 0.537. So that's our curvature, and our radius of curvature, if I just put that in there as well while we are here, that's going to give me 1.863, approximation, 3 decimal places. So that's going to give me kappa. So that's our curvature, that's our answer. And then as a bonus, we've got the radius of curvature. So that circle there will have a radius of 1.863. Approximately, that's the radius of that circle. Okay.